Hello everyone, welcome back to Core Science. I'm Dr. Kumar Samaratunga. So today we will discuss A-level mathematics paper, mechanics paper, May June 2025, paper 43. So so as usual, we have all the instructions and you should be familiar with those instructions. Okay, so let's start with the first question. Okay, here two particles P and Q of mass 0.1 kilogram and 0.3 kilogram respectively are at rest on a smooth horizontal plane. P is projected directly towards Q with a speed of 4u meters per second. At the same instance, Q is projected directly towards P with a speed of u meters per second. After P and Q collide, P moves with a speed of 2 meters per second and Q moves with the speed 4 meters per second. Okay, so the first part, they say that find two possible values of U. So in this case, what you should understand is that they are asking possible two values for U. So then here, if you focus on the situation before collision, in there, okay, they directly say that P is projected towards Q and Q is projected towards P. So then there's no change in directions. But after collision, they don't mention the direction of the movement of this P and Q. So you can think both P and Q are moving in the same direction or they are moving with the opposite directions. Okay, so those are the two situations. So we have to consider those two situations and we can apply the equations. Okay, so now let's see. So first I will make a small sketch to understand better. So before collision, let's take it. Okay, so if we consider before collision case, so in that case we have uh, particle Q. We have particle Q here, and then okay, let's take a copy of this one, and then we have particle P and Q here before collision, and they gave us uh, the speeds and all in this case. So let's see. P is moving with the speed of 4u. Let's say this is 4u meters per second. This is particle P. This is particle Q. And then Q is projected towards P with a speed of u meters per second. So this is before collision. Then let's take the after collision situation. After collision. So in that case, okay, let's draw again. So I will take a copy of this one. Let's take this is particle P and particle Q. And we may have two, let's say two situations. Okay. So if we consider the first case, after collision, P and Q are moving to the opposite directions. Okay. So in that case, let's say P is moving with a speed of 2 meters per second to the other side, and Q, okay, to the other side. Or the second case is both P and Q are moving to the same direction. So 2 meters per second here and 4 meters per second here. So these are the two situations. Let's name, this is P, this is Q, this is P, and this is Q. Okay. So this is the first situation and this is the second situation. So now these are collisions, so we have to consider the conservation of momentum. So you can write considering the conservation of momentum. Okay, so for situation one, you can apply um, the momentum. So let's consider all the momentum to the right direction is positive. So in that case, we can take the momentum of P. The mass is 0.1 times velocity is u, and the momentum of q is to the opposite direction. So the mass is 0.3 times u equals, okay. And then the other thing for the other side. So we are considering here the situation one. So the momentum of q is to the right. So I can write 0.3 times here 4 minus the momentum of p is to the opposite direction or left side. So it's negative. So it's 0.1 times velocity is 2. Okay. So with this one, you can subject u. So this is 0.4 u minus 0.3 u. So then it is 0.1 u. Okay, so then we can find u equals to, here we will have 0.3 times 4 is 1.2, and here you have 1.2 minus 0.2, so then it is 1, right? So 1 divided by here this side we had 0.1. Okay, so in that case you will receive 10 meters per second. Okay, so this is for the for situation one, and then for situation two, again the left side is the same, 0.1 times 4u minus 0.3 times u equals, and in this case here both p and q are moving to the right direction, so then you have to take the summation here. So 0.3 times 4 plus 0.1 times 2. Okay, so in this case you will have here the right side you will have 1.4. So you can write u equals 1.4 divided by 0.1, which is 40 meters per second. Okay, so that part is done. Then they are asking, okay, find the largest possible loss of kinetic energy in the collision. So in this case, you have to understand here we will have two cases for the value of u. So if you want to have the largest possible loss, okay, the largest possible loss you can have when you have the difference of the kinetic energy is high. So after collision, as you can see, the velocities of so you know that kinetic energy is depending on the mass and the velocity. So mass doesn't change here. So it depends on the velocities. So after collision, the velocities does not change 2 and 4. It's fixed. But then before collision, Uh, you have two cases. One is u equal 10 and the other one is u equal 14. So if you use u equal 14, you will have the highest kinetic energy values, right? So then in that case, we have to use uh, uh, 14 for u. Okay. So let's take higher. I will write this one just to be clear. Highest initial kinetic energy can be obtained with u equal 14 meters per second. Okay, therefore, largest kinetic energy loss is we can write total initial kinetic energy minus total final kinetic energy. So in that case, total initial kinetic energy, in that case we have to use 14. So if we apply for particle P, the mass is 0.1 times the velocity is 4 times 14 because the velocity was 4u plus for particle Q, mass is 3 and the velocity was u, so therefore here you have to use only 14. Then minus after collision, velocity of P is 2, so 2 square plus, then for particle Q, it's 0.3 times the velocity was 4. So you should take 4 square. Right. So these are small calculations. So uh, you should be able to use the calculator. Here I'm okay. Since these are simple calculations, I'm not using the calculator. Okay. But for complex calculations, I will show you how to use the calculator. But since these are simple, I'm not going to show you the calculations. But okay, if you simplify this one, uh, you will receive for initial kinetic energy this one minus 13 over 5. So then your final answer will be 918 divided by 5, which equals to 184.6 joules. Okay, so this is the highest kinetic energy loss, or largest. Right, so now let's move to the question 2. Okay, so in this case, a van of mass 4,500 kilogram is towing a trailer of mass 350 kilogram along a straight horizontal road. The van and the trailer are connected by rigid tow bar, which is parallel to the road. Okay, there are resistance forces of Xn on the van and 120 Newton on the trailer. The driving force produced by the van engine is 2,500. The tension in the tow bar is Tn and the acceleration of the van is 0.4. Okay, so find the values of x and value of t. So in this case, okay, let's make a sketch for this one. Let's say this is the trailer and this is our van. So we will write this is the trailer, this is the van, and they are connected with the tow bar, right? And what else? Okay, they say that the force, the driving force, let's say FD. The driving force is 2,500 newtons, and the acceleration acceleration is 0.4 meters per square second. And okay, so we will have here a tension. So let's indicate it as T. And what else? The resistance or the friction force on the trailer is 120 newtons, and on the van it is x newtons. So now in the first case they're asking the values of x and t. So what we can do here, if we consider the system, then we can cancel out t, right? Because we have, like, if we consider this whole system, then t are in both directions, so plus and minus, so we will cancel it, right? So the only unknown one is the x. So first I will write for the system. I'm going to apply F equal ma. So I'm taking the right side is positive, so we have the driving force 2500 minus 120, the resistance, and also the x. And since they are connected with the rigid tow bar, so then we can consider the system has a one mass. So the mass of the van is 4500 plus the trailer is 350, and the acceleration is 0.4. So with this one, you can bring x to the right side and all the other parts to the left side. So with that one, x equals, here you can have 2500 minus 120, minus here 4500 plus 350 means 4850 times 0.4. So when you simplify this, you will receive 440 meters. So this is the value for x. And then we can just consider the trailer. In that case, since they are connected with this rigid bar, then the acceleration of the van and the trailer is the same. So we can apply F equal ma for the trailer. For the trailer, again we will apply F equal ma here. So we have the tension minus the friction, and then the mass of this one was 350 multiplied by 0.4. So in that case, t equal, here we will have 140 plus 120 when it's going to the other side. So the answer is 260 newtons. Okay, so now let's move to the question number 3. Here you can see that there is a velocity time graph. The diagram shows a velocity time graph which models the motion of a particle. The graph consists of 3 straight line segments. The velocity of the particle at time t after passing a fixed point O is v. So this is a general value v for this velocity time graph. The particle leaves O with a velocity of 5. So the initial at time 0, the initial velocity is 5, and the acceleration is 0.75. So in this part, the velocity is 0.75 for the first 20 seconds. The particle then decelerates for the next 30 seconds. So here you have next 30 seconds, you have this deceleration. At time 40, the velocity of a particle is 0. So at 40 here, it's crossed the x axis. So the velocity is 0. After t equal 40, the particle starts to travel back to O, coming to the rest. And okay. So then that means after capital T time, uh, this this particle uh, came back to the original position. Okay. Right. So and also they say that after 40 seconds, it is returning to the original position. So then the graph which is above the x-axis is the forward motion, and the graph below the x-axis is for the backward motion. Okay. So they say, okay, first part is find the value of t. In order to find the value of t, what we can do here? So we know that uh, the top part of the graph for above the x-axis is for the motion, for the forward motion, right? So if you can calculate the area on the graph, so you can have the displacement, the forward displacement. And also if you can write an expression for the area of the graph which is below the x-axis, then you can have the displacement for the backward motion. So the forward displacement and the backward displacement should be same. And in that case, you can find t. But here we will have another problem because we don't know the maximum velocities it reaches, right? So here we don't know this value and we don't know this value. So in this case, let's consider the velocities here. Let's take this is v1 and this value is v2. Okay, v1 and v2. So how we can find v1? Here you can consider the gradient of the first 20 seconds. From that one you can find uh, the velocity. So I will write something like this. Velocity at t equal 20 is v1. Okay. Therefore, you can write k equals, so the y distance is v1 minus 5, v1 minus 5, and the base is 20. 20. This acceleration they gave us as 0.75. Okay. Therefore, we can write v equals, so you can multiply 0.75 by 20 and bring minus 5 to the other side, so plus 5. So you will receive 20 meters per second. Okay, so this value is 20. Yeah. And then we can find the displacement now because we know all the values here. But how you can do that? So here, if we consider this section, this is a trapezium. So you can take the area of this trapezium plus, okay, here you have the triangle, right? So you can take the area of this triangle. So you can take the summation of both. So I will write the displacement at 40, t equal 40. T equal 40. Let's take S1. So first is the trapezium. So summation of the parallel lines, which is 5 plus 20, and divide by 2, multiply by the height, which is 20. So I can write here 5 plus 20 divided by 2 multiply by 20 plus we have the triangle, so the height height of the triangle is 20 and the base is 14 minus 20, again 20. So this is 20 times 20, and when you simplify, you will have 450 meters. Okay, so now you know the area of this part, the highlighted part, right? And the area of the triangle, which is below x-axis, should be the same. But now when you want to write an expression for the area, we don't know V2. So first you have to find V2. So how we can do that? Yeah, since we know the gradient is no, they didn't give us the acceleration. Okay, so this is the acceleration and the particle then decelerate. So here they didn't give us the deceleration. So what we can do? So you can use this part. So the time 20 to 40. You can use that section and find the gradient, and it should equal to the gradient from time 40 to 50, because this is a straight line, so the gradient is the same. So then I can write, we took the velocity as v2, right? So I can write here velocity at t equal 50 is v2. Therefore, I can write, if I take this first part, time 20 to 40, the gradient 20 minus here 0, right? Or height is just simply 20. I will write 20 minus 0. Divide by, so the time 20 minus 40 here. Okay, equals to this small triangle, the gradient of this part. So V2 minus 0. V2 minus 0 divide by 50 minus 40. So with this one, you can write V2 equals here 20 divided by minus 20 and multiply by 50 minus 40 is 10. So 20 cancel. So we have minus 1. So it will be minus 10 meters per second. So this value is minus 10. Okay. Then we can consider the displacement of the return motion. So considering this placement of the return motion, so it's a triangle, so you can write half. So the height is now 10, so no need to consider negative because we are going to calculate the area. 10, and then the time is capital T minus 40, the base. It should equal to 450. So in this case, we will receive, so 10, here 0, 0 cancel, and then 2 times 45 is 90. So T equal 90 and minus 4 goes to other side, so plus. So 130 seconds. And then find the acceleration of the particle from t equals 50. Okay, at t equals 50 to t equal t. So 50 to t, that means this section. So the acceleration I can write equals to height is 10. So that's it. Height is 10 divide by, so the time capital T is 130. So 130 minus 50. Now 8, which is 0.125 meters per square second. So this is the answer. Okay, nice. Now let's move to question number 4. So in this case, okay, 3 blocks of P, Q, R of masses 25 kilogram, 20 kilogram, and M kilogram respectively are held in equilibrium by 3 light inextensible strings OP, OQ, and OR. The strings OP and OR both passes over small fixed smooth pulleys A and B respectively, with P and R hanging vertically below the pulleys. The block Q hangs vertically below the point O. The angle between OA and the vertical is 30 and blah blah. Okay, so find the value of M and the value of alpha. So M and alpha. So here, the first thing is you have to indicate all the forces and their components. Right? That is the most important part. Okay, so now let's consider what are the forces here. Okay. First, you can draw the weights of each masses. So we have weights of each masses here. So this is 25g, this is 20g, and this is mg. And then we have the tension. So first case, okay, from P to A, or let's say P to A and until O, it's a one string. So the tension of that string is the same. Okay. Then we can say that this is T1. So in that case, it's a tension. So the force should be in this way, right? The tension of this string should be in this way since it's a tension. So this value should be T1. Right. And then let's take this one. So here, since this is the same string, so we have the same value for this one. So let's take this is T2 and also this is T2. Okay, how about this one? So we have a tension upwards. Let's take T3. So we have that tension, and also since it's the same here, this one is also T3. So this is T3. This is also T3. Now you should take the components. Okay, so with T2, there's no other components because T2 at point O is vertical. So we don't need to take any components. But if we take T1, yes, with T1 we have this vertical component and the horizontal component. So we can write, since this is the angle 30, so then it is T1 cos 30. Oh, sorry. It become a dotted line, sorry. So this is T1 cos 30 So this one is T1 sine 30. Right. And then with T3, you will have here downwards. You have the alpha angle. So T3 cos alpha, and then you will have another horizontal component. So this is T3. This is T3. Sorry, put that line. So this is T3 cos alpha, and this is T3 sine alpha. These are the main thing we should indicate first. So we don't have any acceleration because the system is in equilibrium, right? So system is in equilibrium, therefore we are not considering the acceleration. So it's 0. Okay, now we can start the calculations. Since the system is in equilibrium here, the particle P, Q, and R, they are not moving. So the forces should be, so T1 should be 25, T2 should be 20G, and T3 should be mg. Okay, so first we will write that one. Since the system is in equilibrium, I can write T1 equals to 25G, which is 250 newtons, and T2 equals 20G, which is 200 newtons, and T3 is mg. So G is 10, so we can write 10 m. Okay. Now, our target is to find m and alpha. So here, if we just consider P, Q, and R, we can't use anything. So we will consider the point O. So the system is in equilibrium, and so the point O is also in equilibrium. It's not moving. So then, in order to be equilibrium at that point, the sum of the total forces in x direction should be 0. The sum of the total forces in y direction is 0. Okay, so we can use that concept here, considering point. Okay, let's take considering the point O. So I will take total force in x direction. So I will consider the right directions are positive. So equal 0. So with this one, I can write, here you have T3 sine alpha minus T1 sine 30. Right? So here T3 sine alpha. Okay, let's say minus T1 sine 30. So with that, we can write here T3 was 10m sine alpha equals T1 was 250, here sine 30. So with this one, you can write, you can divide by m. So 250 divided by 10 is 25, and sine 30 is half. So 25 divided by 2 is 12.5. So m sine alpha is 12.5. Let's take That one as the equation 1. Okay. Then we will consider the summation of the forces in y direction, and I will consider downwards forces are positive. So downwards, what do we have here? We have T2 plus T3 cos alpha, then minus T1 cos 30. Okay. T2 plus T3 cos alpha minus T1 cos 30. Cos 30 equals to 0. This is equals to 0. Okay, so T2 is 200. I will, okay, make it a little bit. I will take a little bit of a space. So this is 200 plus T3 was 10m times cos alpha minus T1. 250 times cos 30. So with this one, we can divide all by 10. So we can write m cos alpha equals to, here we have 25 cos 30 goes to the other side, and minus 20. So I did not simplify 25 cos 30 because we will have some decimal values. So let's keep that like in that way. Okay, so now we have m sin alpha, m cos alpha. So as usual, we can divide them and make tan alpha, and with that one we can find the alpha value. So what I'm going to do is from equation 1 divide by equation 2. So tan alpha equals to 12.5 divide by 25 cos 30 minus 20. And with this one, alpha equals to tan inverse 12.5 divided by 25 cos 30 minus 20. Okay, so alpha equals, so for this one we will use the calculator here. So it's tan inverse, so you have to use shift with tan, and we have a division here, so which is 12.5 divided by here 25 times cos 30, here cos 30, so we have to close the bracket and then minus 20, and let's close the bracket. So then you will receive 82.477 and 477. So we have to keep for one decimal places if it is an angle. So we can write 82.5. So this is 82.5 degrees. Okay, so then how we can find m? Okay, we can simply use equation 1. And so from equation 1, m equals to 12.5 divided by sin alpha equals to here 12.5 sine. So instead of alpha, I'm going to include this tan inverse. Okay, so tan inverse 12.5 divide 25 cos 30 minus 20. Is that one? Okay, again, for this one also, we have used the calculator. So we have a big division, so 12.5, and then divide by, we have sine, and inside sine we have tan inverse, and again inside tan inverse we have division. So 12.5 divide by 25 times cos 30, and so you have to close the bracket, minus 20, and so we have to close the bracket of tan inverse and also close the bracket for sine, then equal. So you will receive 12.6, and we have to keep the answer for three significant figures, so you can write 12.6. Now let's move to question number 5. Here, a van of mass 250 kilograms traveling at speed of v experiences a resistance force of kV square Newton. The constant power of a van's engine is 62.5 kilowatt. The steady speed that the van could maintain when moving along a straight horizontal road is 50. Show that k equals 0.5. Find the acceleration of the van when its speed is 25 meters per second on this straight horizontal road. Okay. So you have to find, okay, first you have to show that the k value is 0.5, and then you have to find the acceleration of the van. So this one is really easy, not very much difficult. So let's indicate what are the information we know. So we have this van and moving with the velocity of v, and we have this resistive force of kV square Newton. That's it. So they are saying that, okay, find the acceleration, and here it is moving with a steady speed of 50. So let's consider that one. Considering the steady speed v equal 50 meters per second, so we can write power v equal fv, right? So with this one, power was 62.5 kilowatt. That means 62,500 watt. Force is given by kV square. So in that case, kV is 50 now, square, times velocity is 50. So with this one, you can find k value. So here you have to divide 62,500 divide, you have to divide by 50 to the power 3, 50 cube. So you will receive for 0.5. Okay, that part is done. And then you have to find the acceleration when its speed is 25. Okay, so steady speed means there's no net force acting on this vehicle, right? So in that case, we don't have that acceleration. So you can simply use the power equal FV. But Then they say that the speed is 25 and there's an acceleration. That means if we have an acceleration means there is a resultant force acting on the vehicle. So one is the resistive force and the other one should be the driving force due to the power of the engine. So we can let's make a sketch for that one. So you have the vehicle here and so we have the friction kv square and then here you have the driving force T and they say okay we need to find the acceleration. Let's say acceleration is a and the velocity they gave us as 25. Okay, now how we can do? We can simply apply F equal ma using F equal ma to the right direction. So we can write Fd, the driving force, the friction, and the mass was 2500 times A. Now how you can find FD? FD is power equal FD times V, and from that one you can write the driving force as power divided by velocity. Okay, so the power in this case, so we can subject A here. So A equals FD. FD is the power is 62,500 divided by now the velocity is 25 minus K is 0.5 times the velocity is 25 square and should divide by 2,500. So when you simplify this one, okay, I will show you quickly how to do that one. So we have a big division and on top we have another one which is 62,500 divided by 25 and then we have minus 0.5 times 25 square divided by 2,500. So we will have 708 and in decimal 0.875. So 708 equals to 0.875 meters per square second. So this is the acceleration. We have another part. Oh no. Yes, we have another part. Now the van begins to ascend a hill inclined at an angle of theta to the horizontal. The van travels along a line of a greatest slope of the hill. Okay. The speed of the van at the start of the hill is 20 and its acceleration is 5a meters per second. Later on the same hill, the speed of the van is 30 and its acceleration is a. The power of the van's engine remains the same. So here 62.5 kilowatt and the resistance of the force remains 0.5 V square. So find the values of A and the value theta. So let's make a quick sketch and so we can see what to do. Okay, so we have an inclined surface. We'll take like this. So the angle with the horizontal is theta. Nice. And then there are two situations. One is the starting point. So, okay, for this case, just let's take this is the starting point. And then there is another intermediate point. Let's take this one like this. Okay. So first let's indicate what are the forces we have. We have the mass downwards, and then we have the contact force, so which is perpendicular, and we have the driving force, right? Okay, so this one is 2500 G. This is also 2500 G, and the reaction force is R. And what they are saying, okay, at the beginning, the acceleration is 5a, and the velocity is 20 meters per second. And okay, the driving force, let's say here FD1, the first situation, here FD2. And for the second situation, the acceleration is A and the velocity is 30. And what else do we have here? Okay, so we have this component, right? So we have, this is also theta, this angle is also theta. And what else? What else? Also we have the friction forces, right? So we have downward the friction force. So these are not mandatory, but it's better if you can indicate that. And also we have the force component of the mass. Okay, so here we will have 2500 G sine theta, and here also 2500 G sine theta. And also we have the friction 0.5 v square. This is also 0.5 v square. Now we need to find two variables a and theta, so we have to have two equations. Okay, so we can consider the beginning at the start of the hill. So I will write of the hill. I'm going to apply along the inclined surface F equal ma. So what do we have here? We have the driving force Fd1 minus the friction 0.5 v square minus the component of the weight 2500 G sine theta equals the mass 2500, and at that time the acceleration is 5a. So Fd is the power divided by velocity, which is 62,500 divided by 20 minus here 0.5 times velocity is 20, so 20 square, minus here I can write 25,000 because G is 10 sine theta equals to here 2500 times 5, so which is 12,500 and I can I can simplify 62,500 divided by 20 minus 0.5 times 20 square. So with the calculator, you can find it. So you will receive 2925 minus here we have 25,000 sine theta equals to this one. So I'm going to keep 12,500A as it is, because with the next one, again we apply F equal ma for the second situation. And so when we divide two equations, we can cancel out a, and so we can simply find theta. Okay, so that's my target. And at the second point, again you can apply F equal ma along the surface. So we have FD2, the driving force, minus again the resistance, and then the force component from the weight. Sine theta, weight is 2500 times, now the acceleration is 8. So now you can write here 62,500 divided by, now in the second position the velocity is 30, minus here 0.5 times 30 square, minus here I can write 25,000 sine theta, and here 2,500. Okay, so again you can simplify 62,500 divided by 30 minus 0.5 times 30 square. So you will receive 4,900 divided by 3, here minus 25,000 sine theta equals to 2,500A. And okay, normally I don't like with this mm, uh, numerators, okay, sorry, denominators. So what I'm going to do is I'm going to multiply by 3 all the equation. So I can have minus, so 25 times 3 is 75. So it is 75,000 sine theta equals 25 times 3. So 7,500. This is equation 2. Now I can simply divide from 1 divide 2. So from equation 1 divide 2, equation 1 is this one. So this part divide by this part. So 2,925 minus 25,000 sine theta divide by 4,900 minus 75,000 sine theta equals to 12,500 divided by this. And okay, so we can simplify both. We can divide by 2,500. So this is 3, this is 5. Then you can cross multiply. So I should multiply by 3. This one 2,925. So we will receive 8,775 minus 25 times 3 means 75. So 75,000 sine theta equals to, then here the denominator of the left side should multiply by 5. So you will receive 4,900 times 5. So 24,500 minus 75,000 times 5. 375,000 sine theta So from this one, sine theta equals to, you can bring 8775 to the right and 375,000 sine theta the other side. Okay, and so you will have 1004 minus 8775 divide by, here you will have 3070, 5000 minus 75,000. So with this one, theta equal sine inverse. So here 24,500 divide minus 8,775 is 15,725 divide by, yeah, 7. So this is 75,000. Sorry. So then it is 300,000. So when you take this one, you will receive 3.0. So you will receive the answer. If you want, I will quickly. Yeah, sine inverse with the shift. So 15,725 divided by 100,000. So it's 3.00. Okay, and then from equation 1, we can find A. So the left side we should divide by 12,500. So from equation 1, A equals yeah, 55 minus, and then 25,000 sine theta, 25,000 sine theta. Here you can from this. So sine inverse is this one. So sine theta is 15,725 divided by 300,000. Okay, sorry, and then divide by this one, 12,500. So I will use the calculator here. So we have a big division, and the 2,925 minus, and I will use a bracket because here we have some multiplication. So 2,500 multiply. Now let me double check. No, it is 25,000. Sorry. So this 25,000 and divide by, okay, let's take something like this, 25,000 multiplied by this one, 15,725, and divide by 300,000. So close bracket, and then 12,500. So why did I receive here an error? Okay, because here I opened a bracket, and okay, here I closed the bracket at a wrong place. So we delete this one, and here we'll put the bracket here. So then here 31 over over 240, and for the decimal places. Okay, so we have to keep for three significant figures, so it is 0.129. 0.129. So this is 25,000 meters per square second. Okay, so that question is done. So now we can start question 6. The diagram shows the vertical cross-section ABC of a rough water slide. The section AB is a straight line of a length of 5 meter inclined at an angle of theta to the horizontal. Okay, where sine theta is 0.8, the point B is 0.5 meter above the level of C. Okay, a man of mass 80 kilogram model as a particle slide down the water slide starting from rest at A. The coefficient of friction between the man and the straight section of a water slide is 0.1. So mu is 0.1 for AB side. Okay. So mu AB. Here mu AB is 0.1. And find the speed of the man at point B. So we have to find the mass of the person at point B. Okay, let's consider. So we can consider that person as a particle. And let's consider point C also. I will keep this one, and so it is too big. So I will put this one here. Okay, at point A. Right. Okay, what else? Let's quickly indicate some information here. Here we need. Okay, so with this one, we know that the hypotenuse is 5, so theta, and so we should know the vertical height of AB. So we can write it as 5 sine theta. So this height is 5, sorry, can write it as 5 sine theta. Okay, and then what else? We have some forces. So we have the mass, we have the contact force here, and also we will have some components of mass. Okay, so let's indicate them also. Here. This is R, this is ATG. So since this is theta, we can write the component ATG cos theta. And we don't know the acceleration. So let's take A meters per square second, and the starting velocity is 0. And we should find the velocity at point B. So let's take it as VB. Also, here we have cos theta, but we know only the sine theta, right? So they gave us sine theta as 0.8, which is 8 over 10, or we can write 4 over 5. So, so we should know, let's say this is theta. So that means this is 4, this is 5. So from Pythagoras, this is 3. So with that one, we can write cos theta is 4 over 5. Sorry, 3 over 5. Here, 3 over 5, which is 0.6. Okay, we need that. Now our target is to find, velocity. So if we can find the acceleration of this motion, and then we can simply apply, how long it traveled. He traveled along this slide. So it's 5. So you know the displacement. If you calculate the acceleration, you know it. You know the initial velocity, and so you can find final velocity using v square equals u square plus 2as. So first, let's find out the acceleration. But for the acceleration, we should know the friction because they say that AB section is rough. So we have a friction force also. So we have a friction here. And that friction F equal mu r. Okay. So now friction force on AB section, we will find that one. On AB section. So F equal mu r. Mu is 0.1 times r is the component of the weight, 8g cos theta. 8g cos theta. So F equals then 0.1. Here 80 times g is 10. Cos is 0.6. So you will receive it has 48 Newton. So you know the friction. Now you can apply downwards F equal ma. Then downwards you have 80g sine theta, the component of the weight, and minus the friction 80 times the acceleration. Then acceleration equals to 80g. So 80g means 800 times sine theta is 0.8 minus the friction is 48 divided by 80. So you will receive 37 over 5 or which is 7.4 meters per square second. Now you can apply downwards v square equals u square plus 2as. So vb square equals u square is 0, 2 times the acceleration 7.4 times the distance traveled is 5. So with this one, VB equals, so here if you multiply 2 times 7.4 times 5, it is 74. So we have to take the square root, 74. We have to take the square root of this one, which becomes 20x. 8.6 meters per second. We have enough space. Now, they say that it is given that there is no change in speed of the man we are passing through B and his speed at C is 11. Find the work done against the resistance force as the man moves from B to C. Okay, so now from B to C, they say that the speed at C is 11. So here is 11 meters per second. And VB, we found it as 8.6. Okay. So now here, as you can see, the velocity we gained, but we have to find out what is the work done against the resistance or the friction. So here's the logic. So you have at the initial point, you have the kinetic energy, and here we have to do an assumption. So at this bottom level, we consider the potential energy is 0. So then B is about 2.5 meters. So then at point B, you have a potential energy also. So potential energy plus kinetic energy. And when you reach to point C, you don't have any potential energy. You have only the kinetic energy. So that means initially you had the potential energy plus kinetic energy, and some amount of that energy reduced due to the work done against the resistance, and then it equals to the final kinetic energy. So let's use that energy conservation concept here. So I will write kinetic energy at point B. Kinetic energy at B. I will write KEB. So we apply half mv square. Half mass is 80 and the velocity was 8.6. So you will receive 2958.4 joules. So here we will receive just 0.4. That's why I get it. In case if you receive more than that decimal places, then you shouldn't simplify it. Okay, you have to use as it is for your final answer. And then we can write kinetic energy at C. Kinetic energy at C, let's say kinetic KEC, again half m square, 80, and the speed is 11 square. So you will receive 4840 joules. Then potential energy. Potential energy at B. B potential energy B equals to mgh, mass, acceleration is 10, and the height was 25. So you will receive here 2000 joules. Okay, so now we have this, and the other one is the work done against the resistance. So we can consider the energy conservation. Energy conservation. We can say kinetic energy at point B plus potential energy at point B. This is the total, and we have to do some work against the resistance. Then we will have that final kinetic energy at point C. So from this one, I can subject W. So W I can bring to the left side, and then bring kinetic energy at point C to the right side. So it's minus. So kinetic energy at point B was 2958.4 plus the potential energy is 2000 minus the kinetic energy at point C is 4840. So when you subtract, you will receive 118.4 joules. Therefore, we can say work done against the resistance is for three significant figures. We can write 120 joules for three significant figures. Done. Now we can move to, I think this is the final question. Yes. So we can move to question number 7. The particle x moves in a straight line. The displacement of x from O at point t at time t seconds after leaving O is s meters per second. Okay, meters. And where this displacement equation is here, s equals 0.3 t square plus 0.6 t for the time duration from 0 to 4. So find the velocity at t equal 4. So we know that when you have the displacement equation, then you can write the velocity v as the derivation ds over dt. So derivation of s is 0.3 t square means 0.6 t plus 0.6. Then we can take at t equal 4 seconds, velocity equals 0.6, t equals 4 plus here 0.6. So this is 0.6 times 4 is 2.4 plus 0.6 means 3. Okay. Then this is okay. For t greater than 4, the acceleration of x time t after leaving O is a, where a is, so they gave you the acceleration equation. There's no change in velocity at x, right? The velocity of x at time t is this one, 14.2. Find the value of t. Okay, so for this one, I will just quickly make a small sketch for you to understand it better. Okay. So we have this starting point, and then we have another point where the time is 4. And then we have another point where the time is capital T. So this is O, and this is time equal 4, and there is another one which is time equal t. So at this point we found the velocity is 3. So they say that it's not changed. And after this 4 seconds we have this acceleration -2, and they say that when time is capital T, then the velocity is 14.2 meters per second. Okay, and so you need to find t. So they gave you the velocity at time capital T, but we have only the equation for the acceleration. But if you have the velocity equation, then you can substitute t, capital T, into that one and equate to 14.2, and with that one you can find it. So in this case, then we have to integrate acceleration equation to find out the velocity. So here a equals 0.3 t half. Therefore, the velocity we can write the integration of the acceleration with respect to time. So it is 0.3 t half dt. So you can write here 0.3 is a constant, so you can leave it. multiply. So we have to add 1 to the power. So half plus 1 is 3 over 2. And again divide by 3 over 2. So here I can cancel out 3 and 2 goes to the numerator. So 0.2. 0.2 t to the power 3 over 2 plus capital C, a constant. So V equals, velocity equals 0.2 t 3 over 2 plus C. So now we should find C, and we know t equal 4, the velocity is 3. So we can use that one to find out where, the value of C. So I can write at t equal 4, V equal to 3. So 3 equal 0.2, here 4 to the power 3 over 2 plus C. So with this one you can find C equals 7 over 5 or 1.4. Therefore you can write V equals 0.2 t to the power 3 over 2 plus 1.4. Now you can apply at t equal capital T. The velocity is 14.2. So I can write at simple t equals to capital T, the velocity is 14.2. Therefore, you can write 14.2 equals to 0.2 capital T to the power 3 2 plus 1.4. Okay, so I can write, if I subject T to the power 3 over 2, then I should bring, okay, 14.2 minus 1.4 and divide by 0.2. Then you will receive 64. And then here 3 over 2 or half. Half means the square root. So you can take the square of both sides to remove half. So you can have then 3 cube equals to 64 square. And then to find t, you can write cubic root 64 square. So yeah, with shift you can have cubic root, and inside you have 64 square, which is 16. So 16 seconds. Then the last part. Find the total distance traveled by x between t equals 0 to t equal capital T, which is 16. So we have, for the first 4 seconds, we have the displacement equation. So distance traveled during the first 4 seconds, let's say. Distance traveled during first 4 seconds. You can, let's say S1. So the displacement equation for the first, this one, 0.3 t square plus 0.6 t. So you can substitute that one. 0.3 time is 4 seconds plus 0.6 time is 4. So when you simplify, you will receive 7.2 meters. Okay. Then we have to find the distance traveled after 4 seconds. So that means from 4 seconds to 4. Okay, let's say this, the distance here. So we have these two distances, right? So this is S1, this is S2. So from time 4 4 to 16. Then we know the equation for time 4 to 16, or when the time is greater than 4. This one. So in order to find the displacement, you have to integrate this one, right? So I can write the distance traveled after 4 seconds. After 4 seconds is equals the integration dt. So in this case, we consider time 4 to 16. The equation was 0.2 times t to the power 3 over 2 plus 1.4 dt. So now let's integrate it. So let's take that distance as S2. So this is 0.2 times the integration of t. So we have to add 1. So 3 over 2 plus 1 is 5 over 2. So I should divide by 5 over 2. Plus here 1.4 is a constant. So the integration is 1. And we don't need to add capital C because this is a definite integral. Okay, so now you can substitute the upper limit and the lower limit. So here I can bring this 2 to the numerator, so it becomes 0.4. So 0.4 over 5 times t, here is 16, 5 over 2 plus 1 over 4 times here 16. So this is the upper limit, and also we have to substitute the lower limit. So 0.5, and then the time is 4, so 5 over 2 plus 1.4 times 4. So when you simplify it for the first bracket, you will receive 104.32 minus for the second one, you will receive 8.16. So which is 96.16 meters. Therefore, we can write the total distance traveled. Traveled is previously 7.2 and now 96.16, which is 103.36. For 3 significant figures, you can write 103. For 3 significant figures. Okay, so with that one, we completed the paper. So thank you very much, and don't forget to subscribe, like, and press the bell button to take the notification, and share with your friends. Good luck, and see you with another paper discussion soon.